Greetings, the Astro 30 here yet again, looking at this abomination of a radio kit. Now, if you watched the first video of this, I'll link that up here so you can look at that if you haven't. The problems I had with this thing is the kit was missing its crystal, which is a 32.768 kilohertz crystal which goes in this Y position here. And well, the radio will not work without it because it uses an RDA5807 IC on the back here. So I went to Jaycar and I managed to actually get a crystal. Unfortunately, it's one of those styles of packages. It does say it's a DT38, but this looks like a surface mount device, which is going to be awfully difficult to deal with. However, I can probably put some pigtails on these little tags that stick out here on the bottom. I'm assuming this is what solders it to the board. Anyway, it does say 32.768 kilohertz, well 32.768 on the top surface of the device, so that's all that really matters. Case style is irrelevant. And just for reference, there's the catalogue number from Jaycar and what it cost, which is $2.95. It's quite expensive, really. But having said that, it's the only way that this radio is going to work. So yeah, so I'm going to get about soldering some pigtail wires onto these tags and then just pass them through the top of the board. Alright, so this is either going to work or it's not. That looks like where you solder to, so that's not a real great issue. Just need to tin this wire so it gives a better connection at the device. I mean, it's going to be ugly, yes, but the point is, as long as it's functional, that's all that really matters. Right, I think that's soldered. As ugly as that is, it should be functional, so I'm going to pop it into the circuit and see if this was worth the effort or not. Are they going to fit through the hole though? That's the question. Barely. I've just got to refashion the ends here so it pokes through the hole. Okay, it's just enough sticking through the underside. Don't want to heat it too long. Just enough to solder it, so otherwise it will just disconnect at the other end. Okay, I don't think I've shorted that. Looks alright. Flipping over. Still soldered on the top. Probably going to leave it proud like that. I don't really particularly care at this stage what it looks like. All I want to know is, does it work? So I'll hook up the power supply once everything gets untangled from my dog clips, alligator clips, whatever you want to call the things. One there. One there, and supply on. Yeah. Right, I got it to work. Yeah, the crystal is actually kind of polarized. Well, that particular crystal. I'll just I did find a data sheet for that particular crystal, and yeah, I'll just draw a quick drawing on a piece of paper to show you what I'm talking about. Now, when you look at the crystal from the top, you've got this chamfered side. There's the device. There's the pins that stick out on the side. And they're marked in this order: 1, 2, 3, 4. Now, pins 3 and 2 are basically not connected to anything, so you don't solder across these 2 pins. The crystal itself is across pins 1 and 4, which is how I've got it configured now. So yeah, I just did a bit of investigation, playing around, and managed to get it. However, the amount of volume coming out of this thing is really excessive. There's no control over the volume. It's got too much gain. I mean, that's its lowest setting, and well, there's no channel there. So, however, it is actually working as a radio now, so I am actually quite pleased with that.
I just bubbled, and they knew me. I was a very serious, intense person, but I had this joy in
But there's too much gain there, as you can hear. It's pretty loud. I may have to mute the audio down a bit.
But I didn't have anybody to disciple me at that time.
Okay, I think I've figured out what they're doing here. They've actually configured the RDA5807FP IC as a bridge-tied load, because pins 1 and pin 3 are each channel's output. So if we look at the underside here, we've got pin 1 here, which goes to, well, the negative side of the speaker, which really it should be positive. I don't suppose it really matters. And this pin 3 here goes to the positive side of the speaker. So those 2 outputs are now bridged. Input comes in over pin 1, 2, pin 1, 2, 3, 4, 5. Yep. So pin 5 is up here. That is 1 negative feedback. So they've got a 10 microfarad capacitor across here from pin 5, which should go to ground, but it doesn't appear to go to ground. I'm not even sure where that goes. That goes to pin 1, 2, 3, 4, 5, 6, 7, 8, pin 8, which is, well, the other negative feedback of the other channel. And if I looked at the data sheet, you'd probably find there is supposed to be a capacitor between those 2 points. This capacitor here, which is another 10 microfarad capacitor, is actually going into pin 1, 2, 3, 4, 5, 6, which is 1 input channel. Pin 7 appears to go to ground. That is the other input. So if I look at the data sheet for that, as we can clearly see, even though the pin numbers are reversed here, they're using pin 7 and for ground and 6 for the input. From what I can tell, it doesn't really make any difference. You just basically tie pins 5 and 8 together via a 10 microfarad capacitor, a 0.01 microfarad capacitor to ground at pin 5. You have 2 Zobel networks and then the speaker driver across the 2. So they're actually using this RDA5807FP as a bridge-tied load. So we're only seeing 1 input at pin 6 in this case, which according to this, it These two inductors are each output of the RDA IC, left and right channels. They're going through two 100 microfarad capacitors for whatever reason to then physically join the two capacitors together on one side and then feed it into the input via a 10 microfarad capacitor. So because the gain is so strong, what I might do is, I'll verify the thing still works, is I'll pop out these two 100 microfarad capacitors, and on one of these ones I'll put some little fly leads in there, and I'll put a variable resistor in there just to see if I can like attenuate what's going into this chip, and make these volume controls actually function a bit more better. I shouldn't really need another capacitor going into a capacitor, because there's already a capacitor here blocking any DC that may be coming off of these particular inductors. So that's what I'm going to do, and that's kind of proud, so I might see if I can bend him down a bit so it's a little bit neater, but that's what I'm up to at the moment. Well, actually, after trawling around on the internet, I managed to find the schematic to the stupid kit. There is a difference in resistor designations, like on this particular board, R3 and R2 are inversed, so the 22 ohm up here is R2, but they've got the RDA5807FP here, crystal oscillator, etc. in the outputs. And here is the supply line. They're coming off of the main DC positive through into the power amp. So the power amp gets the full voltage. So if you use the plug pack, you're getting 5 volts to the IC and 3.7 from the battery. That then gets DC decoupled before it reaches the RDA5807FP via this 22 ohm and 470 microfarad capacitor respectively. However, on this particular circuit board, and I think the rest of them anyway, it's 100 microfarad, but there is still a form of DC decoupling here. So I know that this is not causing this to oscillate because it's DC decoupled, and it sounds fine into another amplifier. This just sounds distorted. As we can see here, it is configured as a bridge tied load, so 1 and 3 go across the speaker, and it's basically following the data sheet. As for the data sheet to this, it doesn't really give you a clear application circuit, but it is basically based on the data sheet. That is supposed to be a ground connection. So when this resets, like the power is turned off and it resets, I don't know what frequency it defaults to, but the volume would default to halfway. The actual data sheet on this particular IC shows that you can actually directly connect 32 ohm headphones via some inductors here directly into the chip without having to go into an external amplifier. How much power is driving those headphones, I don't know. But that was one of the application notes. I personally wouldn't do that. Okay, yes, it does still work, so I've bent him over a bit. So what I'm going to do is I'm just going to hot glue the top end of the crystal to the circuit board, just so it doesn't move around so much. And then once it's hardened, I will then tidy up these solder joints and hot glue it further, so I might need a little bit more. It's a random hole in the PCB there for something. I hate this stuff. Verify that it still works. Yep. Alright, so I can then tidy up this solder joints because they are pretty ugly, if I so can. It's mainly this side that's a problem. There we go, there should be enough solder there now to make a good connection. Alright, so I'll encase the whole thing in hot glue. As ugly as it is, it'll serve the purpose. Alright, I'll let that harden and I'll go back about removing these two capacitors. I mean, I hope you guys enjoy videos like this. I certainly enjoy making them, but I don't enjoy the frustration level involved of having to modify stuff in order to make it work correctly. So those are the capacitors removed. I only need to put two little leads in there so I can connect some test leads to it. I've got one. I did have another one, but it seems to have disappeared. I had 4 of them at one point, and they've all gone because I don't know what I've done with them. I'd rather not use a new piece of tin copper wire because it is like nearly 12 bucks a roll. So, well, I've got one anyway. In fact, I might actually go with the 2 test wires I had used yesterday. These ones here. Just clean them up a bit and solder them in. I think the design of this power amplifier circuit is crap. So I'm going through my signal tracer directly off the output of the IC. I mean, it doesn't reach 0. But it does function okay. Because if we listen to it to a speaker, we've got 100k in series, it sounds terrible. Doesn't really need that capacitor in series with it. Yeah. So unfortunately, the design that they did with this power output is just junk. And if I attenuate it too much, it just starts motor boating. So there's an issue there somewhere. However, I'm thinking a 100k resistor would probably be enough to attenuate it, maybe even a 47k if I can find some. So what I might do is I might just stick a 100k in there. There seems to be
Back to the 50s. In fact, wow.
enough gain there. It doesn't 0, but
This is one of the older ones.
so
But I'm sure it brings back some memories for you.
I just want to know why that's buzzing like that. Could be my leads. Okay, I'm going to go fiddle around with that and come back in a few minutes. I'll just do one for now. Okay, one 100k is in. Doesn't sound too bad actually. I've just lost where my other 100k resistor went. I had two of them. Kind of reminds me of the 1950s. Probably because it is the 1950s. I remember this. Okay. Yeah, that is working. So I'll pop the other resistor in now. Is it like a bad idea to make modifications like this to a circuit? No. If it improves its operability, then I'm all for making changes, because it's obviously not designed right in the first place. It's been running a while off of the provided USB cable. That's where I'm going to really leave this video. Yeah, a couple of 100k resistors in series with each output before the TDA 2822 will make a bit of a difference. I don't know if reversing the speaker leads around would. So I'm going to leave this video here. I'm the Astro30. If you enjoyed this video, please remember to go down below and rate, comment and subscribe if you haven't done so already. Anyway, this is the Astro30 saying, see ya, have a great day.